In this video, we're going to be simplifying complex fractions, and we're going to use another method than the one we used before. This is method 2. So it's simplifying complex fractions. Let's start out by considering an example. Suppose we have the following complex fraction. So let's consider the following. Minus 5x divided by 12. And this is the numerator of this complex fraction. The denominator is x over 3y minus 1 over 6. So for this problem, what we're going to do is use method 2, and then at the end of the problem, I'll compare the two methods by using method 1 and talk about the comparison a little bit. Overall lowest common denominator. So we're going to find a lowest common denominator of all of the different denominators that we have, and we're going to use that overall lowest common denominator to eliminate all denominators and simplify the fraction. Then is I am going to find an overall lowest common denominator. And I will still the LCD. So let's consider the problem that we have right here. So what we want to do then is consider an overall or 12 for the denominator 3y and for the denominator 6. Okay, so for the 6x, I know that what I need is a 2 times 3 times x. So for the denominator, I'm going to have to include a 2, a 3, and an x factor. If I consider 12, well, 12 is the same thing as 4 times 3 or 2 times 2. Right here, we already have 1 2, but what we need is 2 2's, so we're going to put one more 2 in. We do have a 3 already, so we don't need to put another one because we're looking for the lowest common. Both a 3 and a y. We already have a 3. We have a 3 right here, so we don't need to put another one, but we don't have a y. And then finally for the 6, we need a 2 times 3, but we've already got enough 2's and 3's there. So when I calculate the lowest common y. So 12xy is the lowest common denominator. So I will come to the problem that I have right by 6x minus 5x divided by 12 over x divided by 3y minus 1 over 6. So now I'm going to denominator, which we figured out a little bit earlier, and I'm going to multiply the numerator of my complex fraction by that. When you're doing problems like these, you don't want to change the original problem, so you have to multiply, or whatever you do, but you have to multiply or divide by a quantity which is equal to 1. So in effect, we're not changing anything from what we started before. We're just changing the form of it. Well, the effect of this is to take that 12xy and to multiply it by the numerator of this complex fraction and to multiply it by the denominator of this complex fraction. Y by the denominator. X over 3y minus 1 over 6. So let's take one more step to make sure that we all understand this. In multiplying the 12xy by the numerator, and so I'm going to multiply 12xy times the quantity 5y over 6x minus 12xy times the quantity 5x over 12. And I'm going to be dividing by 12xy multiplied by the first term in the denominator and xy by the second term in the denominator. And remember that the second term had a negative right here, so this sign is going to be negative. 12xy times 1 over 6. Well, what we did then allows us now to be able to cancel all of the denominators, because if you look for this first term in the numerator, 6 goes into 12 2 times. The x is also canceled. And so what we have left for the first term is a 5y times a 2y, which should be a 10y squared. For the second term in the numerator, the 12 cancels the xy, which should be a minus 5x squared y. For the denominators, we have the 3 cancels the 12, leaving a 4x squared, and then 6 for the second term, 6 cancels the 12, leaving us 2xy times 1, so that is a negative, a minus 2xy. Now, at this point, you should always try to see if you can simplify your problem a little bit more. And let's consider then the problem that we have right here, 10y minus 5x squared y. Notice that there's a y that is a common factor in the numerator. Let's factor that out. So that would be y times 10y minus 5x squared. And anytime you factor, I advise you to multiply back to make sure you didn't make errors. Y times 10y is 10y squared. Denominator, notice that we have an x in common, so we'll factor that out, and so we have x times 4x minus 2y. And again, let's check the factoring. 4x times x is a 4x squared, a minus 2y times x is a minus 2xy. So the original problem then simplifies to this, and the factoring in this case didn't help to simplify any further. And so the answer to the problem is this quantity right here. Let's write that again. This 5x, or 5y, I'm sorry, 5y over 6x minus 5x over 12. The y over x, and the y is multiplied by 10y minus 5x squared in the numerator, and the x is multiplied by 4x minus 2y. This is now the simplified form of the complex fraction that we started with. So in reviewing this method, remember that what we did was to find a common denominator for all of the various denominators that we have, and we multiplied both numerator and denominator by that quantity, and then simplified. And when we simplified, we ended up x times 4x minus 2y. All right, let's do a little bit of a comparison here with method 1. What would we have done in method 1? Remember that for method 1, what we did is to consider the fraction that we have right here into the form of a over b divided by c over d, so that then we could invert and multiply. And so let's do that. In doing that, to find the lowest common denominator for the denominators in the numerator, and just as we did before, for the 6x, what we need to have is 12, we need 4 times 3. We only have 1, 2. We need to put 1 more in. So the lowest common denominator for the numerators is going to be 12x. So now what we need to do then is change each of the expressions that we had earlier into an expression with a denominator of 12x. And notice that for this fraction right here, what I need to do is a 10y over 12x. For the other side, for the second term, we have a 12, but we don't have an x, so we'll multiply by x over x, and so I'm going to have a minus 5x squared. One way to check your work and see if you did this correctly is 10y over 12x equal to 5y over 6 over 12x. Is that the same as 5x over 12? All right, so for the denominator then, we're going to do the same thing. We're going to find the common denominator. We need to have at least a 3 there. We need to have at least a y. And for 6, we need 2 times 3. We have 3, but we don't have 2. And so is 6y. When we come to this term in the denominator, the x over the 3y, in order to have 6y, we need to multiply the denominator by 2 and the numerator by 2. So we will have a 2x. We're going to need to multiply this by y over y, and so that will give me a minus y over 6. Okay. So once again, let's make sure that we have what we started with. If I block this, 2x over 6y is going to, if I block the 2x, a minus y over 6y is the minus 1/6 that I started with. Now it's in this form of a over b divided by c over d. So what I can do then is invert and multiply. And so hopefully at the end we'll end up with the same thing that we ended up with in method 1. So we will have 10y minus 5x squared divided by 12x, and this is going to be multiplied by the inverse y over 2x minus y. When we do this, we can do a little simplification here. Notice that the 6 goes into 12 2 times. 10y minus 5x squared times y, or y times 10y minus 5x squared. And the denominator is 2x times 2x minus y, and so we would have 2x times the quantity 2x minus y. Is this what we had earlier in the result that we had earlier? Notice that when we had earlier, we had y times 10y minus 5x squared. For the denominator, I could have factored out a 2x from the denominator, and I could have factored out another 2 here, so we could have had a 2x times 2x minus y. So we do end up with the same result. Once again, let's make sure that we understand the difference in the two methods. For this method right here, for method we could invert, multiply, and simplify. For method 2, what we did was to try to find an overall lowest common denominator. We found that we multiplied both the numerator and the denominator by that quantity, and then after we simplified, we ended up with this expression, which is the same as the one we got in method 1. It's up to you which one of the two methods you decide to use. They both have disadvantages and disadvantages. The one thing that you need to do is to be really careful when you do your work. So good luck.